Let us see the principal components of the lathe. Workpiece, chuck, tool post, cutting tool. In a lathe, the workpiece is held in a chuck or between centers and rotated about its axis at a uniform speed. The cutting tool, held in tool post, is fed into the workpiece to the required depth and in the desired direction. The workpiece is rotated and the cutting tool is moved relative to the workpiece. That is why the lathe is also called as turning machines.
This turns the lathe on, and there's a large bar on the board which is a foot brake, and it stops the lathe. There's two controls in the front that we'll be using. One is a large hand wheel, and it moves the carriage of the lathe parallel to the axis of the rotating machine, and the small one moves it perpendicular, so you would use one for facing and one for turning. And there's also a compound that we can set at different angles, and we can use that for cutting angles if we're doing so. So that's the basics of the machine. The speed setup is with the buttons on the control. Right now we've got the machine set up to run at 600 revolutions per minute, which is fine because we're going to be using a piece of brass today. We have a couple of options for tools. We have a high-speed steel tool that we can use, or we have a carbide. The carbide tools are designed for harder materials, and you just change the insert. The high-speed steel is for mild steel, brass, and aluminum and things, and we can use that for turning the brass we're going to use today. So I'm going to use high-speed steel. It's easy for me to repair if I touch it on the chuck, or it gets worn, I can sharpen it very easily. So what we're going to do is we're going to put it into the tool post. The tool post has a bolt in the top. When I loosen the bolt, it rotates around the bolt. So I can swing this around, and it allows me to change the angle of the tool for the different turning operations I'm going to do. So I can tighten that. I'll just set it for now, and once we get the tool in, we'll need to move it to make our adjustments. All the tooling that I need for the tool post and the chuck are on the board next to the lathe, and if everybody puts it back where it's supposed to go, it'll be there for you to use. So now I'm going to show you the quick change tool post. The tool post has a tool holder that can come out. There's a small cam that moves this little block in and out and holds the piece. We have a bunch of different ones, so I can put in 2 or 3 different tools if I'm doing different operations, and it allows me to change them without having to go through all the trouble of setting the center height and everything each one. So I'll lay this in the tool post, and I'll just snug it up for now. Now I'm going to take a turning tool, a right hand turning tool, and I'm going to put it in here. There's another wrench I'll need, which is the one with the small square at the top. I'll use that, and I'll just tighten my tool bit so it can't move. The next thing I really need to do is make sure that I set the tool height on center, which is the center rotation of the chuck turning. So the easiest way to do that is to take a live center, which is with the lathe. There's a Morse taper on the back. There's a Morse taper inside on the tailstock. There's a large bolt that goes down and clamps the tailstock to the lathe, so when I loosen it, I can move the tailstock. I'll bring the tailstock out a little. Inside there's a bolt that pushes it out and moves the tailstock back and forth to quill. So I'm going to just give it a little bang. That holds it in. If I want to remove it, I just go back till it touches the bolt, and the bolt will push it out, and I can remove it. So come off with the bolt a little bit, bang it in, and you're good to go. So this is the center of the lathe, the center of the rotation of the chuck. So what I want to do now is turn the tool so I can see if the tool bit is actually on center. So I'll turn the tool. I can use the smaller wrench, the 10 millimeter, and I can loosen this, and I adjust the height by turning this bolt, and that actually sits on top of the cam holder here and raises and lowers the height of the tool. So I can bring the tool back, or I can bring the center up. I'll just snug it so it won't move, and I'll bring the tool in, and as you see, the tool bit now is quite a bit lower than center, so it wouldn't allow me to cut right to the center of the piece, so it's really important that I center it. So what I'll do is I'll just turn the screw a little bit, that'll raise it up, Just want to make sure I'm not going to hit the tool and break it. And I'll snug it, and right about there, looks right. So now when I tighten this bolt, so now the tool can't move anymore, it's on center. And I can start machining with the tool on center. So I'll move the tailstock back out of our way now. We're going to machine a little piece of brass today. I'm going to do a facing operation to clean it up, and I'm going to do an outside turning operation. Okay? So I'll take my chuck key. The chuck key fits in the chuck, and it's really important to only put it in the chuck when you're loosening or tightening. I'm going to tighten it up, and I'm going to make sure I take it out and put it back on the board so I'll know where it is. Now the tool is not in a position there that I can actually do the machining, so again, I'll loosen the main bolt down the middle, and I'll pivot the tool around. What I want to do now is take this tool and put it in a position so that I can do a facing operation. The tool is ground, it's less than 90 degrees, so I can actually do a facing and a turning. But if you look at it now, the tool won't actually go in and touch the face because the cutting edge is right here on the tip, this tip right here. So what I need to do is I need to rotate the tool so that I can actually just get the point to touch. And if you look there, the point is touching, so I'll tighten up the large bolt and I can perform a facing operation. I also, because it's less than 90 degrees, can move it to the outside and do an outside turning operation as well. So just to show you briefly, I'm going to turn the machine on and do that machining operation. I'll face the part first and I'll machine the outside. So the facing operation, and you know you're on center if it goes right away and takes it. Actually there's a little tiny bit sticking in the middle, so you know it's not perfect, but it's close enough for this. Okay, now I'm going to touch it on the outside, and I can do an outside machining operation as well. Okay, by winding the handle back, and I'm going to put in a Jacob's chuck. The Jacob's chuck then can hold a drill, so if I want a center drill, which I do quite often before I drill a hole, or in this case we're going to center drill and use it to support the end of the shaft. The Jacob's chuck key is on the board as well, so we'll tighten this so it won't move. I can bring it up to the work now. The large bolt that goes down through the tailstock tightens. Push the green button to start the lathe, and I can actually drill a small hole. This is designed so that it drills a small hole for clearance and then puts a taper on, which is exactly the same taper that's on the live center. So now I can move my drill back. I'll remove the drill bit and chuck. I can put that off. I'll put the live center back in now. So now I can take my workpiece, loosen it into chuck, and I can move it out. As long as I got a little bit to hold, I can tighten it. When I move my live center up now, it supports the end, and it allows me to do the machining operation without worry and chatter. I can move my tool in now, and as you can see, I had the tool set up before for doing a facing and a turning operation. Right now we can't do a facing operation because the center is in the way. I can bring in the setup for my cut, and I can feed it along. Just as a point of interest, I'm going to remove the center and show you what happens when I don't support the end. So Caroline is going to move back a little bit and back that toward the wall a little bit so she's not in the way, just in case this part comes out. And as you can see, if your end part is not supported, it's very easy for the piece to hook, and it could be disastrous for the person operating the lathe or somebody standing nearby. So it's really
turning. The tool is fed parallel to the axis of the work to reduce its diameter so that the final diameter is the same at each end. Removing a significant amount of material in one pass is called rough turning. The final lighter cut that creates a smooth surface finish is called finish turning. Taper turning produces a taper along the axis of the workpiece. Tapers are produced by offsetting the tailstock from center line or by using a taper attachment. Short, steep tapers can be turned using a compound rest. Contour turning, or profiling, was formerly performed by having the single-point cutting tool trace a template of the desired profile shape. This has largely been replaced by CNC turning, in which the desired contour is simply programmed into the machine, which directs a cutting tool to cut the contour. Forming is another alternative for generating complicated shapes. The tool having the desired form or geometry is advanced perpendicular to the axis of rotation, reproducing the tool shape in the workpiece. Forming is commonly performed on automatic screw machines. Chamfering eliminates sharp corners from a workpiece and is a good safety measure. Typically, chamfering breaks corners at a 45-degree angle. Grooving creates a groove or recess using a tool that is usually the size and shape of the required groove. Some grooving tools can also widen a groove by traversing side to side after plunging into the work.